Okay, so let's begin with our seventh video. Now that we have completed the data cleaning, data exploration, feature engineering, and table merging processes, our final data frame is ready for analysis. So we will start by first exporting the process dataset into a CSV file. Okay, so just a minute, I'll show you exactly the query. Okay, so the query here, as you can see, is df.toCSV bracket exported churn data.csv comma index is equal to false. Okay. Now here df represents our final merged and cleaned data frame. Then dot to CSV bracket. This function converts the data frame into a CSV file. Okay. So dot to CSV basically converts the data frame into a CSV file. Now this function converts the data frame into a CSV file. Now inside the parentheses, now this brackets I'll call parentheses. Okay. So inside the parentheses we have exported churn data.csv. Now this is the name we are giving to the exported file. Okay. And because we have not provided a separate folder path, Python will save this file in the same working directory where our Jupyter notebook is running, which I'll show you in a minute. Now we write index is equal to false. So why we write that? Because Pandas normally assigns an index to every row, such as 0, 1, 2, and so on. So however, these index numbers are not part of our actual business data. Therefore, index is equal to false tells Pandas not to export those row numbers as additional CSV columns. So after running this query, the clean and processed data set is successfully saved at exported churn data.csv, and I'll show you exactly. So if I go in the SQL project, you can see here exported churn data.csv. If I click on here, it will open the Excel file, and here you can see everything properly, the data in an CSV format. Okay, so I think yeah. So let me just share the main screen now. Okay, so let's begin with the data analysis. Now in this section we'll calculate the important business metrics such as churn rate, retention rate, revenue at risk, customer tenure, escalation rate, complaint rate, and churn risk categories. Now, the purpose is not only to calculate numbers, but also to convert the available customer data into meaningful business insights. So first, as you can see, is df.columns. So normally we do df.columns. So I want to I normally write the query because I want to confirm which columns are available in the final data frame. Okay. So your df is our data frame, and dot columns returns the names of all the columns stored inside it. Okay. Then this query, if you can see churn rate is equal to df bracket, that's list. That square bracket is called list. Churn flag dot mean parenthesis into 100, and then its print churn rate is equal to round bracket churn rate comma 2 comma percentage bracket closed, and we have seen the churn rate is 28.75. So this is like the overall churn rate query. So let us understand first line step by step. Now churn rate, this actually is a variable, is equal to df churn flag dot mean parenthesis into 100. Now on the left side, churn rate is a variable in which I will store the final result. So all this which I have written, I'll store in churn rate, which is a variable. On the right hand side, df churn flag selects the churn flag column from the data frame, right? So the churn flag column has been selected when we write this query. So earlier we created this column using binary values. That is 1 represents the customer who has churned, that's customer who has left, and 0 represents the customer who has not churned, the customer who is still active. So we then use dot mean to calculate the average of values in the column. So why we use dot mean? To calculate the average of the values in the column, right? And so basically this works because the mean of binary column gives us proportion of records containing the value 1, right? The mean of binary column gives us the proportion of records containing the value 1. For example, if 6 out of 21 customers have churn flag of 1, the mean will approximately be 0.2875, okay? So however, 0.2875 is a decimal proportion. So to convert it into 100 into a percentage, we multiply it by 100. Okay? So just in case, if I remove this and let's press. So basically we are getting it wrong. Okay, my bad. So I think we have to still, because it's already stored in that, so it will obviously have that problem. But yeah, we will again make sure it's, yeah, I think it's perfect, but I don't know why it's happening like that now. Okay, trace back most recent call, print churn rate as round churn rate, comma 2. I think it's perfect, but yeah, let me just see what exactly can be done. hmm Well, I didn't do much. I think I have to again. Okay, okay. So I guess I have to just do it again. Yeah, yeah. Just a minute, guys. It will be all right. Sorry for the time delay, but yeah, I just had to show it to you, like why we use into 100, right? So that's why. So just in case if we just remove this, I want you to see the result. And if we remove it, you see it's 0.29%. But that's why we put in plus 100 and we get 28.75. Okay? So yeah, I hope it's clear. Perfect. So we move on to calculating the retention rate. Now, for the retention rate, the retention rate represents the percentage of customers who have remained within the company. So these are the percentage of customers who have left, the churn rate. Okay. The retention rate is basically the people who are active, who are still active, right? So Because churn rate and retention rate together make up 100%, we can calculate retention by subtracting churn rate from 100. And that's what we have done here in the query. So retention rate is equal to 100 minus churn rate is like retention rate is a variable used to store the result, and 100 minus churn rate is it's calculated because we have to get the because we already have the churn rate, so it's very easier to get the retention rate. And then we do the print retention rate is equal to oh this what we say that double colon and round retention rate comma 2 comma percentage. Now in this print statement we display a clear label round the result to 2 decimal. Okay, so we clearly mention that we have to round the result, this result, whatever result comes from 100 minus churn rate, we want it to 2 decibels. Okay, and decimal places and add the percentage symbol. So that's what it's done. Okay, so I hope we are clear with the churn rate and retention rate part. I think it was very easy to get the retention rate because we already got the churn rate, and we always also got to know, like, because we have done this round churn rate comma 2, it has done it like it has made it to 2 decimals plus this percentage part. So yeah, I think yeah, that's that. It's a very easy query, very easy to understand. Okay, perfect. So let's move to analyzing the churn rate by plan type. Now here, as you can see, churn by plan is df.groupby bracket plan type square brackets churn flag dot mean dot mul, that's multiplication into 100, dot round 2 dot reset index, and bracket name is equal to churn rate packed bracket close again, and print churn by plan. So let me explain everything step by step. So I want to go beyond the overall churn rate and understand whether churn differs across different plan types. And for that, I calculated churn rates separately for basic, premium, and standard plans. Now you see, churn by plan, this is like a variable. See, everything which is before the equal to is a variable. So this is a variable, churn by plan. The opening parenthesis allows me to write a query across multiple lines, making it easier to read. The first, df.groupby bracket plan type groups all customer records according to their plan type. This means that all basic plan customers form one group. Premium plan customers form another group, and standard plan customers form another group. So after grouping the data, that's bracket churn flag, select the churn flag column within each group, and then we do dot mean. The dot mean calculates the average churn flag for every plan type. Because the churn flag contains 0 and 1 value, its average represents the churn proportion with each plan. Now dot mul bracket 100 means multiply the result by 100. It performs the same job as writing that asterisk 100, but it works nearly as a part of chained query. This converts the churn proportion into percentage. Then we use dot round 2. So dot round 2 we use because turns each churn percentage to 2 decimal places, and that's what we have got here. So after using group by, plan type becomes the index of the result. So that's why we use reset index. Name is equal to churn rate backed. So reset index converts it back into regular data frame column. It converts this back into a regular data frame column. Why? Because when you are using group by, the plan type, it becomes the index of the result, right? So we don't want that. That's why we do reset index, so that it converts it back into the regular data frame column. Now inside reset index, as you can see, there is name is equal to churn rate packed. So basically this gives a clear name to the calculated churn rate column. So finally, I print the churn by plan, that's a variable. Now the results show basic is 60.00% and premium is 14.29, standard is 22.22. So yeah, that's what it shows. Yeah, I think we have got the gist of it. So yeah, let's move on to analyzing the churn rate by state with the revenue and customer count. This is very interesting. This is the query goes state analysis is equal to bracket df group by state. So we have used the same thing like variable churn by plan, the variable state analysis, then the parenthesis, that's a bracket. In that we have to first we have done group by, same group by state dot. Now group by state actually divides the customer records into separate groups based on the state, okay? So every state will therefore have its own summarized results. Now, what is this dot AGG? So dot AGG bracket, that's this bracket, this whole bracket is the parenthesis. It stands for aggregation. So it allows us to calculate multiple summary metrics within the same grouped query. Now here you can see churn rate PCT. Okay, that's the same thing as this one. The churn rate PCT equals to churn flag, comma lambda x round bracket x dot mean parenthesis into 100 comma 2. So I'll explain it step by step. So this line, that's a churn rate packed, is a new output column created. Okay, so this is a new output column created. Now this column has the churn flag, which tells the pandas which source column to use in this new column. Then lambda x represents the churn flag values belonging to each state. Okay, so lambda x represents the churn flag values belonging to each state. Then comes x dot mean parenthesis. So it calculates the churn proportion for the state. Okay, the average churn proportion. We multiply it by 100 to convert it into percentage. Finally, the round bracket which we have done the x dot mean parenthesis into 100 by 2 rounds the result to 2 decimal places. Okay, Then comes the total revenue part. The total revenue is equal to monthly charges, comma, sum. So here the line creates a column called total revenue. It uses monthly charges and applies the sum function. Therefore, it adds together the monthly charges of all customers belonging to each state. So what it does, it adds together the monthly charges of all customers belonging to each state. More precisely, this represents total monthly billed revenue in the dataset, not complete historical or lifetime revenue. Okay, so now this line, the customer count, obviously creates a new column called customer count. So it counts the number of customer IDs within each state, right? The customer ID and count. So it counts the customer ID within each state. This allows us to understand how many customer records contributed to each state level calculation. And then we go, when we close the bracket, since we have the aggregation of all these three columns, which we have created, that's a churn rate pack, total revenue, and customer count. And then we do the reset index. So the reset index converts state from grouped indexed back into a normal data frame column. So it converts the state, since we are doing group by, into a normal index data frame column. So finally, I space this print state level analysis, and we get the result. So yeah, I hope you understand. So this table allows us to compare the states using three metrics. That's the churn rate packed, total monthly revenue, and customer count. So for example, as you can see, Karnataka shows 100% churn rate, but it contains only two customers. So this is why customer count is important. A very high churn percentage based on only one or two customers may not be reliable enough for major business decisions, right? Here you can see if you have not seen it. Okay, so perfect. Let's move on. Let's analyze churn rate by subscription type. So now I apply the same type of analysis to customer subscription sources or subscription types, which I have applied for revenue and customer count. So it's the same. We create a variable that's like state analysis, subscription analysis. Then we do group by, where we uh, basically use. So basically, this groups the customer according to their subscription type. So df group by bracket subscription type groups the customer according to their subscription type. Then I again use the aggregate function. I create the columns which are important, okay, the same columns, and again reset index and subscription analysis. And that's how I get the churn rate packed, total revenue, and customer count according to the subscription type. I think till here it was very easy to understand. And perfect. Let's move to calculating average revenue per user, ARPU. So in this, I've used the query ARPU is equal to DF. That's a list bracket. Square bracket is called actually a list bracket. Monthly charges into mean parenthesis. So print ARPU, comma round ARPU, comma 2. Yeah. So basically turning it into two decimals. Now, So ARPU, as you know, it stands for average revenue per user. It tells us the average monthly revenue being generated per customer. So here, in this first query, as you can see, ARP is equal to DF monthly charges dot mean parenthesis. Here ARPU is a variable used to store the result. This is the result. DF monthly charges selects the monthly charges column. Okay. So DF monthly charges selects the monthly charges column. Now you may have like one question, how I am actually selecting these columns, and how I'm guessing like if I want to calculate average revenue per user. So these are the key KPIs which are given to me by for the project, and you see how I decide it because I have to calculate the average revenue per user, right? So what I do is I think about it. Okay, how can I calculate the average revenue per user? And I go to this column section. Then I see, okay, average revenue per user, I can use monthly charges. I can use monthly charges and calculate it, right? So that's how I go to the columns and understand it. Okay. So that's how you have to do it. You have to first look at the columns and you have to look at the KPIs given to you and then move forward with the queries and the results. Okay. So dot mean, as you know, calculates the average value across all customer records. And in this data set, the ARPU is around 18.85%. So this means that on average, each customer contributes 18.85 units of monthly revenue. I'm sorry, it's not percentage. I just misread it. So the print statement allows to display the metric with a clear label and rounds it to 2 decimal places. So it displays the metric, this metric. This is the metric, I'm sorry. Um, with a clear label and around it to 2 decimal places. So, ARPU here and 2 decimal places here. So yeah, I hope you get this part. It's very, very simple. We have done it for everything here. So I don't think so I need to explain it to you. Perfect. Always remember the sprint statement. Okay, this is like the most easiest part. You can see it here also. We have done it before. Churn rate. Now churn rate is equal to, then we round it up and we put the percentage also, and that's how we get it. Same with retention rate. Retention rate comes here. We round it up and we get the percentage. Okay, perfect. Let's calculate the average customer tenure. Now, customer tenure represents the number of days for which a customer has used the company's service. So for customers who have churned, tenure ends on their cancellation date. For active customers, the tenure continues until the analysis date. So today equals to pd.timestamp bracket 2026 0516, right? So as you can see in here, I can create a variable called today. So pd.timestamp converts a provided date into pandas date time value. Okay, pd.timestamp converts the provided date into pandas date time value. Okay, so in this notebook, I'm using a fixed analysis date of 16th May 2026 so that results remain consistent with the original project calculation. So in a live business report, I could instead use pd.timestamp.today, which would automatically use the current date. However, the calculated tenure would then increase over time. So first, we use df bracket list brackets tenure days is equal to np.where. So here, as you can see, I've created a new data frame column called tenure days. And I have used np.where parenthesis, which works like an if-else condition. So its structure is check a condition, return one value if condition is true, and return another value if condition is false. Okay. So this where is working like an if-else condition. Remember that. So if first is to check the condition, like df.cancellation.note now, then to return one value if the condition is true, and cancellation date minus subscription start date, and we get one value if the condition is true, and then the third one is to return another value if condition is false. Okay, then this is like today minus the subscription start date. Yep. So let me explain it step by step. Okay. So df cancellation date dot notna parenthesis not now. So this is the condition. It checks whether the cancellation date is not missing, right? So what it checks? It checks whether the cancellation date is not missing. So dot not now parenthesis returns true when a cancellation date exists and false when the value is missing. So as you can see in the second line, I've used cancellation date minus subscription date. So this is a result used when the condition is true. Okay. So if the customer has a cancellation date, we subtract the subscription start date from the cancellation date. So the subtraction creates a time difference, right? And dot dt dot days extract that difference as a number of days. So dot dt dot days here extracts that difference as a number of days. Remember that. Dot dt dot days extract the number extract that difference as a number of days. Perfect. We move forward where today minus df. So this is a result where this is a result when the condition is false. First, when the condition is true. This is a result when condition is false. So if there's no cancellation date, the customer is treated as active, and therefore we subtract the subscription start date from the chosen analysis date. Again, dot dt dot days converts the duration into days. Okay. Remember that it's like a very simple information, but it's very important. Dot dot days function actually converts the duration into days. Okay. Then there is average tenure. Okay. So then there is average tenure, which is df tenure days into mean. So after calculating the tenure for every customer, I take the mean of the tenure days column. Okay. So after I've calculated the tenure of every customer in this query, I take the mean of the tenure days, right? So this gives us the overall average customer tenure, and then we print it. Average tenure day is equal to round the average tenure, which is like 1,452 days. Perfect. So let's calculate the customer age. Now, I'm sorry, I'm just having a drinks break. Okay. So, we have calculated the customer age. First, we have used the today is equal to pd.timestamp.today. Now see, here we have used the timestamp of a date, which is a certain date, okay? But we have here used the timestamp.today. So remember this, today is equal to pd.timestamp.today or a certain date, okay? So timestamp.today returns the current date and time. I store it in the variable today. Now moving on to df customer age is equal to bracket. So first, this basically is creating a new column called the customer age. Okay. Now this column here, as you can see, I have subtracted today minus date of birth into dt.days, which we have used it here also. So why we use dt.days? To convert the difference, like the time difference, into total number of days. Okay. So we use dt.days to convert the time difference into total number of days. Remember that very well. Okay. So here when we do the subtraction of today minus the date of birth, data frame, then we divide it by 365.25. Why? Because we use this 365.25 rather than exactly 365 because it approximately accounts for leap years, right? And then we close the bracket and then we use as type dot as type integer, bracket integer. So after division, the result may contain decimal values such as 44.3 or 30.8. So dot as type integer converts the result into a whole number. It removes the decimal part because age is usually reported as completed years. Okay, so here we get the result. As you can see, we have the customer ID, date of birth, and customer age. Yep, so we get the result here. Then moving on to calculating the revenue at risk. Again, this is the variable revenue at risk, and this is how we calculate it. So in this analysis, revenue at risk represents the total monthly charges associated with customers who have already churned. So therefore, this metric can also be described as monthly revenue lost due to churn. Okay. So as you can see, revenue at risk is equal to df.log. So I have created the variable called revenue at risk here. And then I use .log, which allows us to filter rows and select a specific column. So .log allows us to filter rows and select a specific column. Now here, df churn flag double equal to 1. So this is basically a row filtering condition. It selects only those customers whose churn flag is equal to 1. Remember that. So it selects only those customers whose churn flag is equal to 1. In other words, it keeps only churned customers, right? So normally, as you remember, the churn flag which were 0 were active customers and 1 were cancelled, like the people who have cancelled it, right? People who have churned. So that's why it specifically selects only those customers whose churn flag is equal to 1. This is like a row filtering condition, no? That's why. Remember that df, when we use a data frame, double equal to 1 is actually a row filtering condition. Okay? What does dot log do? Remember that? It allows us to filter rows and select a specific column. Okay? And same with double equal to 1, it does the same. Okay? Then there's monthly charges. So after filtering the rows, I select the monthly charges column. That's what it means. And then then the bracket is closed. Now you see the bracket which is used is a list bracket. So when it's closed, it's into point sum parenthesis is used. So point sum parenthesis adds together the monthly charges of all churned customers. So what it does, it adds together the monthly charges of all churned customers. Okay? Dot sum parenthesis adds together the monthly charges of all churned customers. Remember that. Now, then we have to print revenue at risk is equal to. I think the print function is very easy to understand, so that I don't think so. There's some doubt in that print function, but yeah, we make it to 2 decimal. Round revenue at risk, comma 2 is like making it to 2 decimals. Okay, and that's why we get the revenue risk at around 73.94. But this means that the churn customers collectively represent 73.94 units of monthly revenue. It's important to clarify that this is monthly revenue associated with churn customers. It's not total lifetime revenue loss. Okay, perfect. So let's move on. We move to check the unique escalation values. So before calculating the escalation rate, I first inspect the values stored in the escalation column. So I've used a data frame, escalation df bracket, that's list bracket escalation dot unique. So dot unique returns every distinct value appearing in that column, and df dot escalation selects the escalation column. Okay. So as you can see, the output shows NaN, Y, and N. So here NaN is like missing values, Y means the compliant was escalated, while N means it was not escalated. So this validation step is useful because it confirms exactly how the category values are represented before we write a condition based on them. Perfect. So let's move on with to calculate escalation rate. Okay. So once we got the escalation unique values, we calculate the escalation rate. So now I calculate the percentage of customer records that contains an escalation. So first, as you can see, df escalations double equal to y. So this compares every value in the escalation column with the letter y. So for every matching record, Python returns true. For every non-matching record, it returns false. Okay. So this is a variable, and this basically compares every value in the escalation column with the letter y. So for every matching record, Python returns true, and for every non-matching record, Python returns false. What does dot mean? You know it. So when calculating the mean, Python treats true as 1 and false as 0. So therefore, the mean gives us the proportion of records where escalation equals y. Now we have done into 100. So we multiply the proportion by 100 to convert it into percentage. right? Then we print it. I don't think so I need to explain you print, but because print is the most easiest one here. It's just this one which I need to explain, which I hope you understand, okay? Because my main aim to create these videos is not just to showcase my portfolio project, but is also to help you understand why I wrote the certain query, okay? Perfect. So as you can see, the escalation rate is around 19.5%. This means approximately 19% of the customer records in the dataset involved and escalation. Perfect. So let's calculate the average complaint per user. Now, as you can see, this first one, as you can see, this is a variable, average complaints. I don't think so I need to mention that now. Then there's a data frame. This actually selects the complaint count column. Okay. When we put it into df dot, remember it selects the column. Okay. And then when we do dot sum, it adds together all the complaint counts. Divide by df customer id dot n unique. So this selects the customer ID column, obviously. Remember that if we use data frame and we use square brackets, it selects that column. Okay? Remember it very clearly. N unique counts the number of distinct values of customer IDs. So using the distinct customer is safer than simply counting rows because in some data sets, the same customer may appear multiple times, right? And then we print it. I don't think so I need to explain the print one, but yeah, that's how we do it. So finally, the output we get is 0.43. This means the dataset contains an average of approximately 0.43 complaints per customer. Okay, moving on to analyze the correlation between escalation and churn. Now, this query is very important because normally in many portfolio projects or many people which I see, they don't use the correlationship method because, and this can actually stand out in the resume also. So this would help if you put it in your project. So now I have analyzed whether complaint escalation and customer churn move together. For this, I calculate correlation. So correlation measures the strength and direction of the relationship between two numerical values. What correlation does? It measures the strength and direction of relationship between two numerical value. So before calculating it, the escalation values must be converted from text into numbers. So as you can see, df escalations is equal to np.where, then bracket df escalations double equal to y, comma 1, comma 0. So here I've used np.where parenthesis brackets, that's a double bracket, to encode the escalation column. Okay, so I've used it to encode the escalation column. So the condition checks whether the escalation value is equal to y. If the condition is true, it assigns the number 1. Otherwise, it assigns the number 0. So that's what this query is all about. NP stands for numpy, where is basically like a if-else condition. Remember that. Okay. That's why we use, like, for example, if the condition is true, we use 1. If the condition is false, we use 0. Okay. Here in this case, if the value is equal to y, it's 1. If value is not equal to y, it's 0. And this is a new escalation column. Remember that. So one important point is that missing escalation values are also converted to zero in this query. That means they are treated as non-escalated. So next, I create a smaller data frame called CORR-DF, that's correlation data frame. Now inside the double brackets, I select only two columns instead required for the analysis. That's escalation and churn flag. Dot drop now, which is here, parenthesis, removes any rows containing missing values in these selected columns. So what does dot drop now does? It removes any row containing missing values in these selected columns. This ensures that the correlation calculation uses complete pair of values. Okay? Remember, dot drop now, parenthesis, removes any rows containing missing values in these selected columns, in these both columns. That's what it means. Okay? Then we use the correlation, and we use the correlation variable, which has stored this function in the core corr.df. Then, so here I've select the encoded escalation column and apply the dot cor function. Inside the dot cor, I provide the churn flag column, as you can see. So, sorry, here, as you can see here, I have provided the churn flag column. So pandas then calculate the Pearson correlation coefficient between the two variables. Okay. So the result is stored in correlation, and then we print correlation between escalation versus churn is equal to, and round the correlation to two decimal places. And that's how we get the correlation to around 0.77. So the correlation values usually the correlation values usually range from -1 to +1. A value close to +1 indicates a strong positive relationship. Therefore, a correlation of 0.77 suggests that escalated cases are strongly associated with churn in this dataset. However, correlation does not prove that escalation directly causes churn. It only tells us that the two variables are strongly related. Also, because this dataset is small, findings should be treated as an analytical signal that requires further validation. Perfect. Now we move on to our last section of our data analysis, that is to create churn risk categories. As you can see here, so instead of asking stakeholders to interpret a score such as 27, 62, or 91, we classify each customer as low, medium, or high risk through the churn risk categories. So that's why I convert the numerical churn score into simple business friendly risk categories. First, we use the conditions. So this is like the list called conditions, which we have used here. So this conditions, as you can see, we have used here in the churn rate data frame. Okay. So first condition checks whether the churn rate score is less than 50. So this is the data frame churn score, and if it's less than 50, So the customer meeting this condition will be classified as low risk, right? Then the second condition checks two rules together. The churn score must be greater than or equal to 50, and it must also be less than 70. So the and symbol here means both condition must be true. Remember that. This and symbol, if it's there, that means that both the conditions must be true. So customers with a score of 50 to 69 will be classified as medium risk. Now the third condition checks whether churn score is 70 or above. Now, these customers will be classified as high risk. Okay. Now, I've created this list called choices. Each choice corresponds to a condition in the same position. So, the first condition maps to low, second maps to medium, third maps to high. Then I create a new column called churn risk. This is a data frame, there's a new column. And then I use np.select parenthesis, which is useful when we have multiple conditions and multiple possible results. So when we use np.select, when we have multiple conditions and multiple possible results. Remember that. We use np.select parenthesis when we have multiple conditions and multiple results. Right? We have multiple conditions and multiple results. That's when we use np.select. Bracket conditions, which is this, choices, and default is unknown. Now, the default value is used when none of the conditions are satisfied. Okay? So in this case, the customer will be labeled unknown. Then, so for valid churn scores, all values should normally fall into one of the three categories. But including a default value makes the query safer if unexpected or missing values appear. Perfect. Now I select the new churn risk and churn score dot sample and 5. So finally I select the new churn risk column and the original churn score column. So this is the new churn risk column which we have created from here. Okay. And the original churn score column. And I've selected just 5 samples. That's why I've written dot sample 5. So this actually dot sample 5 displays 5 records. Okay. This helps us validate that the categories have been assigned correctly. For example, a score of 27 should appear as low risk. A score of 62 should appear as medium risk, or 62 or above. But I don't see medium risk here. Uh, Maybe it's not there. But maybe in the tail section we can get the medium risk. Yeah, I think we can get in tail section. Yeah. And then a new score of 91 should appear as high risk, right? So it's like high risk. So this new churn risk category can later support the customer retention campaigns, dashboards, and targeted interventions. So with this, we have completed the data analysis stage of the customer churn project. We begin by calculating the overall churn and retention rates. We then analyze churn across plan types, states, and subscription types. We also calculated key business metrics such as average revenue per user, customer tenure, customer age, monthly revenue at risk, escalation rate, and average complaints per customer. Finally, we analyzed the relationship between escalation and churn and created simple churn risk categories based on customer churn scores. The important point is that these calculations do not simply produce numbers. They help the business understand where churn is highest, which revenue may be affected, how customer complaints and escalation relate to churn, and which customers may require early retention support. In case you don't know what churn is basically the customers who are leaving, who are canceling the subscription. That's churning. Okay. So yeah, in the next stage, we'll move on to data visualization. So I hope you learned something from it. I have explained most of things in proper detail. So anyway, thank you so much for watching, guys.